Hey guys, BuildZoid here, and today we're going to be going over some general information about the Ryzen AM5 CPU memory system as it relates to overclocking. Also, if you'd like to support the channel, there are links in the description that you could check out, and it would be much appreciated. And with that out of the way, let's get into it. So what we have here is a heavily simplified diagram of an AM5 CPU. Right, we got our two CCDs, we got the Infinity Fabric links to the I/O die. We've got the unified memory controller over here, the DDR physical interface, which is controlled by the memory controller. Then we have our DDR5 memory sticks. And I also drew out all the connections, well, some of the connections, not technically all of them, but yeah, some of the connections for the memory. I'll point out that the CAD bus doesn't actually bounce from chip to chip like this. It's more like a straight line, but it connects to every single chip that it like passes under. And like it just, for the clarity of the diagram, it didn't really make sense to draw it that way. So yeah. Anyway, so that's our AM5 CPU and all the components we're going to be talking about on it today, or around it. Because technically the memory isn't part of the CPU, but anyway, here's the clock regions, right? So the Infinity Fabric obviously runs at FCLK. The Unified Memory Controller runs at UCLK. And the memory and the physical interface for the memory run at MCLK. So yeah, that's our clock regions. And then we have voltages, which we're not going to explain right now because there's a lot of them and it doesn't really, like, I'm not really sure how to approach this. The first thing I want to address is the Infinity Fabric synchronized and like one-to-one mode? And the answer is no. When you put your MCLK to UCLK into one-to-one mode, it refers to these two clocks, you know. So this stuff, actually I should be in orange, so that refers to this stuff and this thing. It has nothing to do with the Infinity Fabric clock, okay? And this is just a thing that bugs me because I see a lot of people going like, oh, one-to-one mode is like synchronized. No, it's not. Because in one-to-one mode, let's say you're at DDR5 6000, right? And I'm going to just throw the units up on top here. We've got our, oh, I guess we can start with the H and then I'll just put an M in front of it. There. So we got our megahertz, right? So in one-to-one mode, MCLK is 3000 megahertz because DDR is double data rate. So the clock is half the data rate. And then the memory controller runs at the same clock as the memory system. So 3000 megahertz. And I know this gets, I mean, I say memory system, but like memory physical interface. That's also the phi comes from physical. If you're wondering why it's called a phi. Anyway, so yeah, so these two run at 3000 megahertz and your FCLK runs at 2000 megahertz. Now, funnily enough, there are like FCLK ratio options all the way up to 3000. They just don't work. So you can't synchronize the Infinity Fabric to the memory clock. It cannot be done. Well, you can't synchronize to the memory controller in one-to-one mode unless you drop your DDR5 speed to like 4000. And I've tried this. It's a terrible idea. Like, because your memory just ends up incredibly slow and everything sucks and it should never be done. So don't. So yeah, one-to-one mode is not synchronized. It just isn't. Okay? It's like on Ryzen 3000 and like 5000 series CPUs, it could be synchronized because your memory was like, your memory controller would run at like 1900 megahertz, right? And your Infinity Fabric could run at 1900 megahertz. But on Ryzen 7000, 9000, the memory controller is capable of doing 3 gigahertz and the Infinity Fabric just isn't. So it doesn't synchronize. So anyway, yeah, that's the first thing I want to address. Now, in terms of clocking this, what do you want to do? So, if you're at 6000 in one-to-one mode, what is like the optimal Infinity Fabric? Because it's not synchronized, right? Like, again, this is 3000 and 2000 are not the same thing. It isn't synchronized. So what kind of frequency? Actually, you know what? Let's draw it out like this. So obviously the Infinity Fabric options that you have are like 2033. And I do remember, like my easy Hynix timings video recommends using 2033. The reason that video recommends that is that in the AGSA that I was testing at the time, there was a bug where 2033 FCLK would bump the UCLK, and that would just like give you a nice little performance boost. It would also like bump the MCLK. Like it was like a very mild memory overclock. Yeah, that doesn't happen on newer AGSAs anymore. That got fixed like a long time ago. So that's no longer relevant. But anyway, so 2033 exists, 2066 exists, 2100 exists, 2133, 2166, 2200, and then of course we have 2233. And there's like I mentioned earlier, there's more ratios than that. It goes all the way to 3000, but like it is very rare for a CPU to be even remotely functional at 2233. Okay? So basically, that is like if you have a CPU that works at 2233, as in like it's actually faster at 2233, it's a unicorn. So that's not really an option. Is like 2233 is not really an option. Anyway, so 2000 isn't synchronized, but there is a slight benefit for having a 3:2 ratio because of just like the buffering of the data between the memory controller and the Infinity Fabric. At 3:2, there's some like scheduling optimizations of the buffer that works out in your favor in terms of memory latency. So this isn't the worst thing ever, but it's not synchronized. And because it's not synchronized, that like minor optimization of the buffers really isn't that significant. And you can blow straight past it by just running like 2100 FCLK. Because at this point, the Infinity Fabric is going to be fetching data from the buffers like 5% more often, which is just faster than, you know, having like a slight optimization of like 3:2. So if you're at 6000, your options are basically like you basically don't want to run that, and you don't want to run this. But this is good, this is good, this is good, this is good, and this doesn't work because your CPU isn't that good. Right? But yeah. So those are basically your options for 6000. Now, what about 6200? So 6200 1:1 runs 3100 on the MCLK and 3100 on the UCLK, right? Because 1:1. And it's worth noting that even, say, this is faster than this. Okay? More UCLK is just more better. Now, I generally recommend that people buy DDR5 6000 CL30 kits, because if you get incredibly unlucky, your CPU won't run 6200. Also, they don't really make 6200 rated memory kits, which is just like the stupidest thing ever as far as I'm concerned. Like an optimal Ryzen like works on 90% of CPUs, you know, low latency Ryzen memory kit would be like a 6200 CL28 kit. Not a 6000 CL28. But anyway, actually a 6200 CL30 is going to beat a 6000 CL28 kit. Just straight up. Like it's just faster. Because that extra UCLK is kind of a big deal compared to 2 ticks of CAS latency. Anyway, so in 1:1 mode, you always want to run the highest possible memory speed. Okay? Always. There is never a reason to be like, oh, I'm going to run... Well, unless you care about, like, idle power consumption. Because the... I guess, yeah, let's bring it up. Like, this video is going to be a disorganized mess. So, the thing with 1:1 mode is the limiting factor for what memory speed you can run in one-to-one mode is not MCLK. Okay, if you've got Hynix memory chips, they're good for like 4,000 plus megahertz, right? They do not care for Hynix. Now, if you have like Micron or Samsung, it's not, you know, you're not gonna you've got problems. But if you've got Hynix memory sticks, so like a 6000 CL30 kit, a 6400 CL32, you know, you can go 4,000 plus. So the memory doesn't care. The PHY itself also is good for, I mean, I don't know that I'd say it's definitely good for 4,000 plus, but like 3,800 is trivial for the PHY. Now, the unified memory controller, that doesn't clock that high. The max uclk at ambient temperatures is basic, and this is if you get incredibly lucky, is 3.3 gigahertz. Right, so 3,300 megahertz. And with the uclk, how am I going to fit this? Actually, I'm just going to give myself a new layer for this. So with the uclk, you've got a very simple relationship. More VSOC equals more... This is not going to fit. Like, I'm going to later run out of space, is what I mean by that. Like, it's going to fit now. Then again, it's on a different layer, so I guess I could just hide it. So, more VSOC equals more uclk. Right? And the basic relationship is like 100-ish megahertz is, like, will require, like, usually, like, needs about 100 millivolts. Right? So what this basically means, if you have a chip that does 3,000 at 1 volt SOC, right? It'll do 3,100 at 1.1, and it'll do 3,200. I don't know. I should just use at. Yeah, that might actually be faster. Well, too late. That'll work at like 1.2 volts, right? And actually, it's usually like it gets progressively more. So it would actually be more like this would be more like 1.09, and this would be more like 1.2. And then like 3,300 is going to be like at say 1.31, 1.32. And so this isn't going to work on most CPUs, right? And if you're incredibly like actually like the 7800X3D that I have, like it needs more than 1.1 volt SoC just to run 3000. Because it really sucks. And that's the CPU that's currently recording this video. So, you know, that's kind of the thing, is just like if your chip needs a ton of voltage for like 3000 or 3100, it's gonna like, it's not gonna do 3200. Right? If you need like 1.2 volts for 3100, you're not doing 3200. If you need 1.2 volts for 3200, you're not doing 3300. And so, like, really bad is, so, yeah, like, bad CPU is like 3000 at like 1.2-ish volts. And that's obviously SoC voltage. And a golden CPU would be like 3300 at less than 1.3 volts SoC. And there's nothing you can do about this. Like whatever your chip does is what your chip does, right? So if you get a chip that like works at 3300 1.3, good for you. And most chips don't, right? And how often do you see chips that work at 6400? I just straight up don't know. So that's kind of the situation with the uclk, is that it is hard limited by the memory controller. In one-to-one mode, it's all about just getting lucky with the memory controller. Now, technically, you could get a motherboard that's so incredibly bad that going over 3000 is a problem. But if you don't have a literal dumpster tier motherboard, like 6600 is trivial. Even like 7200 on the memory speed is not, because the motherboard doesn't impact the unified memory controller directly. I mean, I guess your voltage regulation for SoC could be so incredibly terrible that it would affect the uclk, but I feel like you'd have to try to do that, because the SoC power rail on the CPUs doesn't experience harsh power transients. It just doesn't. The IO die pulls a relatively constant amount of current, so the SoC voltage regulation is actually quite trivial from a power delivery perspective, because the IO die just pulls kind of the same amount of current all the time. So you don't really have to worry about that. Like, your motherboard's power delivery is not going to ruin your uclk, but, if the motherboard has a garbage memory topology, that might limit your MCLK. So that's like the one way that you could have a uclk limit that isn't from the memory controller itself. But generally, like, if your motherboard is like, basically, if your motherboard can't run DDR5 6200, like, you're really scraping the bottom of the barrel as far as like motherboards go there. So it's not really a concern. Like, the worst AM5 motherboard I've used, and admittedly I've avoided, the like super cheapo ones, but the worst AM5 motherboard I've used still works at like DDR5 7000, which I do think is kind of a massive fail, but like, because all the other ones work at higher speeds than that, but like, it's not going to limit your uclk, right? Unless you get an absolute garbage motherboard. But what will limit your uclk is your SoC, right? Like your silicon quality. So anyway, yeah, so that's what limits the uclk, and I've now realized that I've kind of screwed myself on space with this over here. So give me a second as I try to correct that. I guess I could use the eraser. No, it's a bit bigger than it was before, but we'll take it. Actually, no, I won't. That bugs me. Oh, man, I really don't like how GIMP has the pop-out system for the like tool options. Like, because I'll go grab like brush size and it'll pop the tool options out, and I hate it. Anyway, so where was I going? Right. So, let's say you have a CPU where you can do like 3100, right? You want to run 3100. Okay, like, you want to run this even if you're at like 2000 FCLK. Obviously, it'll be faster it'll be significantly faster if you run 2066, right? Because this right here is the 3:2 ratio. And then alternatively, if you want to push past that, you basically want to go to like 2166. Now, there's a decent chance you won't be able to run that, but if you can, that's going to be faster, right? So basically, the approach for maxing out the memory performance of any Ryzen CPU is just push uclk as high as it goes, and then set the Infinity Fabric to match the uclk. Right? And then the 6400 1-to-1, right, that runs at 3200. In my experience, 6400 working is not super common because of that 3.2 gigahertz uclk. I have like one CPU that actually does 3.2 gigahertz uclk, and that's the 9950X. And that's, as far as I know, that's not because the IO die for 9000 series got better. I just got lucky. I've heard of 9000 series chips that with 1.3 volts SoC won't do 3.2 gigahertz uclk. Okay, so don't just assume that because you buy a 9000 series, your DDR5 6400 kit is going to work. It might not, which is why I don't recommend 6400 for Ryzen systems. I recommend 6000 because 6000 will work Okay, even on the worst CPU ever, it will still work. 6400, on the other hand, especially in my experience, very often doesn't work in one-to-one mode. So anyway, at 6400, the 3-to-2 ratio is obviously just straight up 2133. And your alternatives are getting incredibly lucky. Yeah, like you don't really have alternatives. Like technically 2200 can be, depending on the workload, like if you have something very memory bandwidth intensive, more FCLK will always help, but from a latency perspective, 2133 is generally best. And then of course, if you get very, very lucky with your CPU, it might do DDR5 6600. And then you can do, I mean, I shouldn't be saying it'll do 6600 DDR5, because like I mentioned earlier, the MCLK is really not a problem. Your Phi is definitely, like I'd say definitely good for 3800 plus. Your Hynix memory sticks easily 3800 or 4000 plus. And so the question isn't is the CPU going to do DDR5 6600? The question is the memory controller going to do 3.3 gigahertz? And for the vast majority of CPUs, the answer is no. But if you get lucky and you get a chip that does do 3.3 gigahertz UCLK, then obviously, ideally, you'd want to run 2200 Infinity Fabric. But there's a problem. So if you look at the FCLK region, you'll notice we have 3 voltages sort of involved with it, right? We have VDDG CCD, which is the voltage used for the GMI link on the CCDs. As far as I know, this voltage is like down-regulated from VDD MISC. Then we have VDDG IO die, which is used for the GMI link going from the IO die to the CPU. So that's like used for the physical interface of this actual connection. Yeah, that's also generated from VDD MISC. And then you have the SoC voltage, which I am actually not entirely certain what exactly in the Infinity Fabric it powers, but it powers something in the Infinity Fabric. And the bad news is that where UCLK just goes up as you raise SoC voltage, like more SoC, more UCLK. But with Infinity Fabric, it is unfortunately not that simple. Max FCLK, in my experience, usually occurs between 1.1 volts SoC and 1.2. And if you go above 1.2 volts SoC, it will often get worse. You'll go from like, you'll go from like, let's say you do 2200 at 1.15 volts, you'll have good performance. Then you bump it up to like 1.25, performance gets worse, you bump it to 1.3, and you're not even able to get into Windows anymore. Now, this does vary by CPU. I have seen some CPUs that can do 2200 FCLK at 1.3 volts SoC. I don't have one of those. In my experience, 2200 FCLK needs relatively low SoC voltage in order to function. And so that basically means, if you get incredibly lucky with your memory controller, and it actually does 3300 megahertz at less than 1.3 volts SoC, chances are your SoC voltage in order to run 3300 UCLK is too high to be stable at 2200 FCLK. However, like I mentioned earlier, 6600, even with say 2133 FCLK, is still going to be faster than this, right? Because you just have fresher data in the buffers at higher memory speeds. The memory controller is simply processing memory requests faster. So that's why it's always like the number one priority is push the UCLK as high as it goes and then go worry about your FCLK. Don't worry about the FCLK first because it doesn't matter. UCLK first, then FCLK. Right? And another thing with the Infinity Fabric is I would generally, like especially for daily systems, I would generally not recommend trying to push it to its absolute limits because it has really aggressive error correction. So it generally will not crash, but it can cause stuttering, hitching, audio cuts, just weird slowdowns if it's slightly unstable, right? And when I say slightly unstable, like you can have error correction that occurs once every 10 minutes. And the way that's going to manifest, especially with audio or like workloads, but audio is the most obvious. When the Infinity Fabric corrects an error, it just retransmits a bunch of data. So it just stalls processing on whatever you're doing, which means you just get an audio cut. For a few milliseconds, there's just not going to be any audio. I mean, your whole system's basically going to freeze for a couple milliseconds. Which means pushing the Infinity Fabric unnecessarily high is really bad for your like system functionality, right? You're going to get audio cuts, stutters. Don't. Just like, as far as I'm concerned, for daily setups with the Infinity Fabric, like if 2200 is very unstable, 2166 might be unstable, and the safe option is 2133. That's like the brain dead way of dealing with this. Instead of trying to, come up with some way of detecting the errors reliably, it's much easier to just go like, okay, this is very unstable, so this probably isn't completely stable. Like if this is very, very unstable, then this probably isn't going to be this probably isn't stable. This will be. That's at least my experience, is like my best chip, which does 2200 FCLK, it kind of does 2233, right? But even at 2200, it still like occasionally gets an error. And it's really hard to tune those errors out because they're very infrequent. But it works perfectly at 2166. But that chip also like kind of works at 2233. So that's so the brain dead way of dealing with the Infinity Fabric is just find the point where it just doesn't work and then go 2 steps back from that, right? So it's like, okay, and when I say it just doesn't work, I don't mean it doesn't boot. I mean, you can clearly see that it's unstable in the OS. Like you're getting errors, in like calculation errors, you're getting crashing, that kind of thing, right? Because a lot of chips will straight up just not boot 2233, or even 2200. So you want to find a speed that boots, but is very unstable, and then you want to go 2 steps back from that, and that's basically guaranteed to work. Right? So it's like, doesn't boot, very unstable, probably not, so hypothetically, it's like, doesn't boot, kind of like very unstable, probably unstable, good. Right? Because the one that like this transition right here is like, this might be stable, it might not be, and it's really hard to prove. So, and also the other thing in 1-to-1 mode, like this is never synchronized, right? Like at best, you have like a slight latency benefit of the 3-to-2 ratio where the buffers just happen to line up with each other a bit more frequently. But it's never synchronized. So you don't really have to worry about like, oh, it's not like Ryzen 5000 where if you're at 1900 FCLK, everything's amazing. Like if you're running DDR4 3800 with 1900 FCLK on Ryzen 5000, everything's amazing. And if you drop the FCLK to 1866, everything goes down, like performance goes down the drain. That doesn't happen with 7000 series or 9000 series because there's no synchronization, right? Like, this isn't synchronized. This is like a scheduling optimization. So you don't have to worry about like, oh, I need to maintain the perfect ratio between the Infinity Fabric and the uclk. No, you want the highest possible uclk and the highest possible FCLK. And if, the 3-to-2 ratio doesn't work, that's fine. You still just try to run the highest FCLK possible. And you prioritize uclk. Unless you for some reason don't want to run very high SoC voltages, which like your idle power consumption does go up quite significantly if you're at like 1.3 SoC. And also that SoC power consumption does eat into your CPU's power budget. So if you're on the stock power limit, that's another reason to like not necessarily just mash SoC voltage into the chip. But if you're doing like static overclocking, then yeah, max out the, like for 1-to-1 mode, max out the uclk, and then go worry about the Infinity Fabric. And in order to max out the uclk, Well, the starting point would be like set your SoC voltage to 1.3, right? Work your way up. At some point, it's just not going to work, and then like go to a uclk that does work. So let's take my 9950X as an example. At 1.3 volts SoC, it will boot 6600. It'll even run some benchmarks. Not very well, but it will run them sometimes. A lot of the time it'll error out, but it'll kind of work. But yeah, not great. And so at 6400, it like even at 1.2 volts, it's still relatively stable. Right? So you basically set your SoC voltage to 1.3, figure out where it stops working, then back off to a ratio where it does work, and then you can lower the SoC voltage to bring down your idle power consumption. Though I wouldn't start lowering the SoC voltage until after you've tightened your memory timings, because if you start with the SoC voltage first, you could put yourself in a situation where the memory controller is kind of borderline on the stability, and that can that can lead to like issues with pushing the memory timings lower. So yeah, and this is probably the reason why most AM5 motherboards default to 1.3 volts on the SoC. Is because yeah, like as a starting point, like you probably don't want to leave it there, but as a starting point and as a compatibility fix, right? Because a lot of CPUs might need like 1.28 to run 6400. Well, if you're a motherboard vendor, if you want to make those 1.28 chips work at 6400, you just shove 1.3 into them and it'll work. I mean, there's a lot of chips that even at 1.3 won't run 6400, but you're minimizing. Whereas if you set the SoC voltage to say 1.15, well, there's going to be a ton of CPUs that aren't going to do 6400 at 1.15, right? Because they're just not going to run 3.2 gigahertz uclk. So that's that. So that's the one-to-one mode. Number one, like for one-to-one mode, number one priority is max the uclk and then go worry about the fclk. And also to max the uclk, basically just raise SoC voltage. That's really all there is to it, unless your motherboard is incredibly bad. So that's the one-to-one mode. Now, two-to-one mode. So two-to-one mode exists because, like I mentioned, the PHY is good for like 3800 plus, the memory is good, like Hynix memory sticks are good for like 4000 plus, but the memory controller is not good for either of those frequencies. So 2-to-1 mode exists because in 2-to-1 mode, well, for example, 6600 runs 3300 MCLK, right? But UCLK gets dropped to... I can't do that kind of math in my head. Oh, it would have been 1650. Yeah, anyway. It's dropped to 1600 megahertz, which is trivial. This will work on every CPU. Now, one thing to sort of be aware of with the 2-to-1 mode, if you buy a 6400 rated memory kit and you turn on Expo or XMP, the motherboard will probably default to 2-to-1 mode. Because the default behavior is as soon as you go over 6000, it goes to 2-to-1 mode. Now, there might be some motherboards that don't do that, but generally speaking, it'll go 2-to-1. And that's bad, because now your memory controller is processing memory requests about half as fast. Now, it's not a complete disaster, because you have to keep in mind that the memory controller is still way, way, way faster than DDR5 memory chips. Because DDR5 memory chips take forever, right? Like, you might have a read request from the CCD that goes up the Infinity Fabric into the memory controller, and then the memory controller needs to figure out, okay, where is the thing that we're trying to read in the memory, and then it needs to give, send that memory request to the memory, and this all happens pretty quickly, right? And then the memory sits there, like say I send a read request, and we're lucky enough that we have the row we need to access is already open. So we might go like read, and then it's like, I want to read column. Actually, I don't know. Are columns in numbers or letters? And it doesn't matter. Let's say I want to read column 10 of whatever row is open. Well, if you're at like DDR5 6000, say CL30, yeah, that's going to take 30 clock cycles to get done. So the memory controller running at like 1.6 gigahertz isn't really a problem because the memory reacts to a read request in 30 clock cycles, right? So the 2-to-1 mode isn't like, this isn't, oh, my memory latency doubled, because like, yeah, your memory controller now takes longer to process memory requests, but most of the memory latency is internal to the memory chip. It takes forever for a memory chip to take data and output it, okay? So this whole like, hey, I want to read something, that happens way faster than how long it takes the memory chip to actually go like, oh, here's the data, okay? So that's just something to keep in mind, because that really bugs me about like a lot of memory discussions, or people like, oh, if we put the memory chip closer to the CPU, no. It takes forever for the memory chip to like it takes for the longest part of a memory read is like from inside the memory chip to the output of the memory chip. That takes absolutely forever as far as the rest of the system is concerned. Okay? This wire length is completely irrelevant compared to how long it takes for the data to travel like microns through the memory chip. Actually, maybe a few millimeters. I'm not really, like, I'm not sure how much wire length is inside the memory chip involved in actually moving the data to the output buffers of a memory chip, but it still takes forever, okay? So the data basically moves like a fraction of a millimeter, and that just takes 30 clock cycles, and then it hits your memory controller and gets dumped onto the Infinity Fabric in a fraction of the time that it takes for the memory chip to do pretty much anything. Oh, and that's assuming that you have the correct row open, right? If you need to open a different row, that takes even longer. So anyway, so 2-to-1 mode, this looks really bad, but it's really not that bad because most of the memory latency is from the memory, not from the memory controller, even when the memory controller is literally running at like half the speed. Because RAM is really freaking slow. But anyway, either way, I wouldn't recommend that you actually run 6400 2-to-1. Because yeah, like if you have like the 6200 one, like, you know, let's say you have a chip that doesn't do 6400 1-to-1, 6200 1-to-1 is just gonna beat 6400 2-to-1, right? Like that's just faster. Now, I think technically, well, 6400 optimized can beat like 6000 Expo, but, well, Expo timings kind of suck, so it's not really much of an achievement. Anyway, so from 6400, you have other ratios, like, I mean, there's 6600. We're not going to go through all of them, right? But like the next one where it's like, oh, you definitely need a 2-to-1 mode is 6800, right? Like there's, like, if you go sub-zero, the uclk actually scales with negative temperatures, so you might be able to run like high uclk at like negative 20 degrees Celsius or something, and you might be able to run 6800 1-to-1. But generally speaking, if your CPU is at ambient temperatures, 6800 1-to-1 is not happening. So that's like definitely 2-to-1 mode. Then you have like 7000, 7200, 7400, right? I'm not going to write all of these out. 7600, 7800, and with 7000 series, 8000 is kind of a stopping point. And the reason this is kind of a stopping point, I guess I should say Zen 4 instead of 7000 series. Well, the thing is that core architecture is also used on APUs, which don't have the same memory controller, so that I don't like that. So yeah, that's like end for 7000 series. The thing I don't like about it is like I have two 7000s now. But anyway, yeah, so that's the end for 7000 series is a DDR5 8000. And the reason for this is because there are technically ratios in like 8100, 8200, 8300, and they're like visible in the BIOS, but they're broken. So if you try to set them, it just reverts to 88,000 for 7000 series. Now, 9000 series fixed this. If you have a 9000 series CPU, you can actually run like 8100, 8200, 8300, 8400. But if you're on 7000, if you want to go past 8000, you need to go BCLK, which overclocks everything and can cause major issues. So not really an option for a daily setup. Now, the other issue you run into is, like I mentioned, the PHY is definitely good for like 3800 plus. The memory sticks are good for like 4000 plus. The motherboards, if you're like, a lot of motherboards will kind of stop somewhere around here. At least like 600 series boards will really like, you're gonna really like, the 7600 is potentially quite difficult to do. So that's sort of the issue with 2-to-1 mode, is that, yeah, you get kind of, you know, like it's like, okay, so the uclk is no longer a problem, but the motherboards are. And the thing is that if you have like a dialed in 6200 or 6400 setup, this is slow, this is slow, this is slow, this is slow. This is kind of competitive with 6200. This is kind of competitive with 6400. This is actually just straight up faster than everything in 1-to-1 mode, but there are very few motherboards that can run this. And also, I'm not entirely certain that this is consistent across CPUs. So, yeah. So that's so basically, how do I do this? Right? Like, this is MOBO problems. Like, from like 7000 and up, it is motherboard problems. A lot of 4DIMM, like 600 series boards, you're going to be maxing out at like 7400. So, yeah, anyway. So basically, and the thing is, like I mentioned, performance-wise, these kind of suck. So, I mean, this really sucks, right? Like this, the bottom end of that really, really sucks compared to dialed in 1-to-1 setups. But for 2-to-1 mode, so basically 2-to-1 mode, in my opinion, really only makes sense from like 7600 and up. So then, at so that's the part that we're gonna like actually worry about. So 7600, that runs 3800 on the MCLK, right? And the UCLK runs 1900. And now you get options, because you can run 1900 FCLK, right? Or you can also run 2200. Now, at this point, these are equal, which means they're synchronized. Yeah, that actually synchronizes. So this is one thing that, like, this is basically one of the main reasons I'm making this video. 1-to-1 mode on Ryzen 7000 and 9000 series CPUs doesn't synchronize with the Infinity Fabric. It just doesn't. 2-to-1 mode does. But in 2-to-1 mode, your memory controller is running much slower. And also, like 7200 is just bad, because at 7200 your MCLK is 3600, your UCLK is 1800, and your synchronized Infinity Fabric is 1800, which is literally Ryzen frickin' 5000 levels of Infinity Fabric clock, which is not good, right? So this is really slow. Now, the good news is that these incredibly low UCLKs, you can run very low SoC voltage, right? I recently had a video showing DDR5 7800 running at 0.9 volts SoC, because for DDR5 7800, you're on 3900 MCLK and 1950 UCLK, which synchronizes with a 1950 ratio on the Infinity Fabric. And 1950 UCLK, you just don't need a lot of voltage for that to work. And you also don't need a lot of SoC voltage for 1950 Infinity Fabric to work, right? So it works at like 0.9 volts SoC voltage, so really good idle power consumption, especially compared to like a 6400 setup in 1-to-1. But yeah, the annoying issue with with a 7800 setup is that it also doesn't work on most motherboards. So, you run into that problem. Um, so yeah, and so this also synchronizes. Another annoying thing specifically for 7800 is accessing the 1950 Infinity Fabric ratio is really hard on some motherboards. Like you just like yeah, like there are some motherboards where setting the Infinity Fabric to 1950 is just ridiculously difficult. Um, so that's another sort of minor complaint, but that should get that might get fixed with like BIOS updates eventually. Um, anyway, at 7800, you also have the option of running 2200 FCLK again. I mean, that's assuming that your CPU, because the FCLK behavior didn't drastically change. It's just that when you're in 2-to-1 mode, you don't have that whole like, hey, you see, like you don't need a ton of SoC voltage, so this suddenly stops being a problem, right? Because when you're in 2-to-1 mode, running the SoC at 1.1 volts or 1.2 volts, like that's just fine. Like whatever, you can run whatever SoC voltage your Infinity Fabric needs instead of whatever SoC voltage your uclk needs, because your uclk is super low, right? So if your chip can do 2200 in like, let's say you have a chip where like 1-to-1 you can run 2200, but you can't run 2200 at say like 6000 you can run 2200, but at 6400 you can't, because at 6400 you need a really high SoC voltage. Well, with that kind of CPU, if you're in 2-to-1 mode, 2200 is not going to be a problem. However, for gaming, the synchronized option is faster because the latency is lower, and like it's quite a bit lower. This isn't the like the 3-to-2 thing in 1-to-1 mode is like basically nothing. Like it's actually annoying to try measure that difference because of how small it is. In 2-to-1 mode, the difference from synchronizing the Infinity Fabric is so big that even 10, like this is more than 10% extra Infinity Fabric clock, it's still noticeable. However, there are certain applications that prioritize memory bandwidth, and in that scenario, 2200 is going to be like 2200 FCLK is going to be better than 19, like synchronizing the FCLK. But specifically for gaming, in 2-to-1 mode, you want to synchronize the Infinity Fabric. Though I wouldn't recommend like 7200. I don't think that would be a good idea because that is really low, right? Like that at 7200, I think 2200 FCLK is probably going to be best. But from like 7600 and up, you basically want to synchronize. And then of course 8000 is a very nice, clean, 4000, 2000, nope, 2000 synchronized setup, right? So this is really quick. Really, really quick. Like this is just straight up, like if you can get this to work, it is just straight up better than 6400 1-to-1. Now, if you can get this to work, right? And it's worth noting that when you're in 2-to-1 mode, if you're stress testing 2-to-1 mode, there is a lot, like you can get errors like 6 hours into a stress test, or even like 10 hours into a stress test. So that's like another argument against 2-to-1 mode is that it is really like, it requires a good motherboard. It's annoying to stress test. It is potentially it is really fast, and you do get lower idle power consumption, but it's a lot harder to set up, right? Basically, is like my main complaint for it. So from like a daily system perspective, like 1-to-1 mode is really convenient because like it's fast, it's easy, you don't need a fancy motherboard. As long as you don't do something incredibly stupid with your settings, it's probably just gonna work. 2-to-1 mode, because you're running extremely high MCLK, right? Like the trace quality of your motherboard becomes a problem. Pin contact in the CPU socket could potentially be a problem. I've not actually experienced that with AM5 myself, but it is a potential like issue. Pin contact with the memory sticks could potentially be an issue. Right? Your VDDQ not being set just right, because this is the actual signaling voltage, right? So this VDDQ directly affects the signal quality between the memory chips and the PHY. So if your VDDQ, like at 1-to-1 mode, VDDQ, you can be off by quite a bit. Like there's like a pretty big window of VDDQ values that'll work in 1-to-1. In 2-to-1, if it's not, as like especially if you're at the upper limits of 2-to-1, if your VDDQ isn't just right, it doesn't work. Same thing for VDDIO and VDDP, right? Because VDDIO is, as far as I know, the signaling voltage from the PHY to the memory chips, and VDDP is like an internal voltage for the PHY itself. If your VDDP is too high, not stable. Too low, not stable. Same thing with VDDIO. Too high or too low, it's not going to be stable. Also, what's extra annoying is because these are like straight up, like these interact with the actual traces of the motherboard and like the drive strength resistances and the termination resistances of the memory controller and the memory chips, depending on the BIOS version and depending on the motherboard, what VDDIO you need and what VDDQ you need can be completely different, right? So like some motherboards will like high VDDIO, some will like low VDDIO. Same for VDDQ. And also it varies by BIOS version, and it's just incredibly annoying. So that's like the downside to 2-to-1 mode is like, yeah, you suddenly really have to worry about the signal quality between your memory chips and your memory like physical interface, instead of just like worrying about, hey, is my uclk going to do whatever at high like at a like at some SoC voltage. So that's the bad news about 2-to-1 mode. But if you get it working, it is really fast. And then going past 8,000, I actually don't know what happens. Because 8100 doesn't have a synchronization, right? Because that's 4025. Well, it's 4050, but it's 2025, and there is not a 2025 infinity fabric ratio. There's also not a 2050, and there's not a 2075. There is a 2100, but like 8,000 is hard to do. 8400 is like a whole nother level of hard to do, right? So, yeah. So 2-to-1 mode is a thing, and it's fast, but it brings up a whole bunch of other issues. Now, interesting options like, let's say you have a potato chip that like doesn't do 6200. If your motherboard doesn't suck, 7600 is quite easy to do, right? Again, like if your motherboard doesn't suck, but like, you know, if you do have like a absolutely potato CPU, 7600 is an interesting option. Whereas if you have a good CPU and you can run like, well, good CPU, like 6200 isn't great. I'd say that's like average, maybe below average. But like this right here is a nice, easy thing to set up if your chip can do these speeds, right? I mean, really these speeds. And especially if you can do 6400, like 7600 is kind of a waste of effort as far as I'm concerned, unless you really care about your idle power consumption. Because again, at 7600, your idle power draw is going to be like you can run very low SoC voltage, right? Which for 6400, like especially if your CPU isn't that great for 6400, you might need like 1.29, 1.3 SoC. And in that case, like, yeah, 7600 is going to save you a bunch of power, maybe. So 2-to-1 mode is interesting from like it's interesting from an idle power consumption perspective. Also, there's like, you can just go further than you can in 1-to-1 mode potentially. But it's really motherboard limited and a massive pain to tune, right? So that's the downside to 2-to-1 mode. But on the flip side, like it does synchronize the Infinity Fabric, right? Not, you know, again, not that big a deal. Because yeah, you gain some latency from the synchronization of the Infinity Fabric, but you also lose some latency because the memory controller just takes significantly takes somewhat longer to process memory requests. But like the reason I bring this up is that DDR5 8000, like, because I've seen a lot of comments around Ryzen where it's like, oh, 2-to-1 mode is just completely useless. That's not true. It has its uses. It's just, in my opinion, it's not easy enough to configure to be worth using. Like, if it just worked, then sure. but it doesn't just work, which is the main argument against it currently. So maybe with like BIOS optimizations and like, you know, memory, like motherboard, like memory controller to, I mean, PHY to like motherboard to memory chip tuning, DDR5 8000 might reach a point where it does just work. And if that happens, then like I could see one-to-one mode just becoming irrelevant overnight. Because yeah, if you could run 8000, you would run 8000. But currently, running 8000 is not really a, you know, like it's really hard for a lot of boards. So that's the main argument against it. And I think that basically covers everything. Oh, one thing I forgot to mention is that if you are trying to push the FCLK, like sometimes fiddling with the VDDG and VDDG voltages can stabilize it. And when I say fiddling, I mean raising them up or down could help. It's not really set in stone as to which direction is going to be best. It kind of varies. A lot of the time, messing with the VDDGs just isn't actually going to achieve anything. So the Infinity like max FCLK, I would say is mainly Silicon Lottery and then just not running crazy. Like, I mean, if you win the Silicon Lottery hard enough, you're going to get a chip that does 2200 even at 1.3 SoC. But if you get a chip where it's like borderline for 2200, it's going to be about like keeping the SoC voltage reasonable, potentially. Right? uclk is just straight Silicon Lottery, right? Like, just there's really nothing more to it than that, as far as I'm concerned. And then MCLK, motherboard. It's all about the motherboard, kind of about the, like, that's assuming you have Hynix memory chips, right? If you have Samsung or Micron, then the motherboard won't matter if you have Samsung memory chips, because they just don't go over, like, 6800 as far as I know, so, yeah. But MCLK is that's, you know, like, if you have Hynix memory chips, that's a motherboard, VDDQ, VDDIO, VDDP, BIOS thing as to what your max MCLK is going to be. And then the main thing is that one-to-one mode is not synchronizing the Infinity Fabric, okay? It's just not doing that. 3 gigahertz does not synchronize to 2 gigahertz. It just doesn't. 2-to-1 mode does synchronize. Like, depending on how you set it up. So, anyway, hopefully you found this somewhat useful. Yeah, that's it for the video. So, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon and like the Patreon Spring store where there's like shirts and posters and stuff, and a Bandcamp, and I'm also like developing a game. There's like links in the description that you could check out. Would be much appreciated. And yeah, that's it for the video. So thanks for watching, and goodbye.